Okay, it is 3:50 Eastern, so let's get the party started. So I'd like to introduce myself. My name's Kelsey Young, and I'm one of the co-chairs of this workshop. Joining me today is Amanda Ostwald, who is our awesome early career facilitator, who you just heard from chairing the third session of today, and who's going to help me wrangle this crew for this breakout session. So thanks for being here. I'm going to go ahead and share slides. I'm going to attempt the dreaded take notes live in front of other people today during the breakout. Myself and Amanda are going to be kind of walking us through this session, which is, again, historical lessons learned for mission activities. So the other breakout is covering kind of everything that happens up to boots on the moon, and we're going to talk about kind of structuring science support during real-time operations. This rules of engagement slide Jose just briefed, but just a couple things now that we're here and ready to go. Community participation is vital. My ideal way to spend this next hour is to hear from each and every one of you of the 41 people on this call. So I really hope that we can gather as much, dialogue and input from all members of the community here today as possible. Please mute your microphone when you're not speaking to prevent the dreaded echo and sort of background noise. To speak, everybody look to see if you have a raise hand function in Teams. You should all have a little hand that looks like a high five. Please raise your hand if you'd like to speak, and I'll just call on you. That will prevent, everybody stepping on each other. And if you don't have the raise hand, you can just enter in the chat, like raise my hand or something similar, and I can call on you. If you don't want to speak up out loud, you can ask questions or comment in the chat window, which you should also have in the Teams sort of infrastructure here. So feel free to chat your questions or comments or whatever in the chat box, and I'll try to keep that open as I take notes, and Amanda is also going to help me monitor all of that. And I won't cover the rest because Jose covered it in the spirit of jumping into things. So in terms of leading questions, we just kind of want to cover the three main topics that we heard from, especially in the second session today. What worked well and what can be improved from lessons learned from Apollo? What lessons learned can we leverage from Martian rover exploration? And what can we leverage into Artemis from how ISS operations work today? So looking at the participants here, I think we have great representation from all of those different groups. So I think we have the right people here to have these conversations. So Amanda and I were trying to take notes real time during today. Got to stretch our fingers for the next hour. And I tried to dump some initial kind of questions, comments, thoughts that I heard in each one of these three categories as we walk through today. Certainly not comprehensive, but it was just intended to sort of like get the ball rolling for this conversation. So I thought we could try to spend about equal time on each. So I know we have a lot of people who are interested in Apollo and Mars and ISS, but I thought we could try to sort of step through them, leaving time for each one of the three categories. So starting with Apollo, what worked well and what can be improved from the design and function of the Apollo sort of science support structure during Apollo. So I'll just briefly step through what I have. If you'd like to respond to a point here, great. If you'd like to add something, great. Keep in mind that the overall deliverable from this workshop is a set of reports that will summarize our major findings, intended to represent this is how the science community feels about the best way to do real-time science support during Artemis. So some findings that I heard, and again, these can be tweaked. This is just me taking notes and pulling from Amanda's notes. This first one kind of gets at Jose's breakout, but Artemis crews should include somebody with field geology expertise. We want to find a way to get early career people involved. That's really critical, and it's something that Apollo did well. Real-time tracking data to keep awareness over where the crew is critical for science team situational awareness. Rigidly scripted EVA times did not work for science objectives. And Apollo astronauts served as a field PI and took some ownership over those science objectives, which is a model that really helped science productivity and should be followed for Artemis. And some things that came up that I was curious to hear your more direct feedback on. How often did the Apollo crews have science-focused conversations with Houston? So we heard about, briefing and debriefing. I think it was Jim that mentioned that. And that's a chance to, feed forward lessons learned for Mars when there's going to be a time delay, but also just that are really critical to, having the crew debrief to Houston and having Houston be able to provide their insights on, what we've learned scientifically. What can we learn about science decision-making authority from Apollo? We heard a lot about that decision-making authority in multiple talks today, and that's going to be really critical to maximize the efficiency of these science-based conversations. What can we learn about how to bridge the Apollo SSR with the rest of the broader flight control team from Apollo? I think there were a lot of talks that touched on that, and I think that's going to be really critical and really complex when we think about all of the samples that are going to be collected, the instrument data that's going to be collected, and especially as we get toward the longer term missions, how all of that science is going to be able to be accommodated. And what lessons learned can we leverage about deploying instruments and the associated data management problem that comes with that during operations? So I think what we want to focus on is a set of findings that summarize what we liked about Apollo and what lessons learned we can draw forward. So I guess I'll start with, how do you feel about these findings, and what findings can we add to that? And I'm going to remind you to use the raise hand function, and I will try to monitor that for today. Any comments? Jim?
Yeah. Does anybody else have a question first? I don't want to dominate here. I had a couple of comments. Okay, well, so these are great. Okay, one thing I think that's really important that's emerged here is the question of how the real-time data tracking is really critically important, because we're going to have so much greater technology here, and that's going to be really important. So the team on the ground, that is to say on the Earth, will have more information than we had in Apollo for sure. And so that, whatever is going on there, maybe some of that needs to be controlled from the ground. For example, in Apollo, Ed Findell, he was called Captain Video because he ran the cameras, the TV camera, but we weren't in the same room as he was, so we didn't have any control on that. So increasing the control on the ground and integrating with the science will be even better than we had before, for sure. Okay, that's an improvement for sure. I don't like to use rigidly scripted EVA timelines. They must be that way, because you have to plan, you have to prioritize. The key here is that just recognize that you have flexibility at all levels. You saw that with Dave Scott on Apollo 15 and the seatbelt assault. We saw that throughout the Apollo missions. I mean, if you make a discovery, wow, yeah, go for it, okay? And the orange soil in Apollo 17 was really amazing. That reset a lot of the priorities, et cetera, in the short term there. And I think the other thing is that the communications between the science, I like the idea of de-emphasizing the back room. I think that's badly put. It worked fine in Apollo. Everybody understood. We were right next door, actually. But still, I think don't use that term. Use a science support room, or whatever you want to use, to elevate it from today's nomenclature where it might be looked upon negatively. But I think the communications between the science support room and the basically the mission operations control room, okay, which is where the real control, where the flight director was, that needs to be improved. Okay, it worked okay in Apollo. Jim Lovell did a great job on the Apollo missions, but at the same time, I think there could be an improvement there, and maybe elevating it to some level would be useful. A science and engineering partnership of some kind to help make sure things happen. Because Jim was great. He was just absolutely great, but he didn't know all the details, of course, of the geology. And like on Apollo 15, when we made the decision to, like Dave Scott in the SIVA, and then on the first EVA said, hey, there are no boulders down there. We thought there might be boulders, and that was going to be the whole exploration strategy. And so we had to redo that. And, basically I had to explain to Jim, okay, here's what we need to do, summarizing it. And he basically, it was sensory overload. So he basically handed me his badge and said, take my badge, go down there, check with a flight director, and then tell that to the Capcom. And so, I grabbed Jack Schmidt and we both went down, and that's exactly what we did. But that's just an underlying kind of like example of why I think we can elevate that a little higher to the level that there's some kind of partnership there that would have the input. So Yeah, so that's I think an important lesson from our discussions today. I was very impressed, by the way. One last thing, I was very impressed with the structure of the ISS and related EVA people. I mean, I think they're doing absolutely the right thing, and it's just great to have all that kind of background and input and engaging the scientists, et cetera. That's science and engineering synergism at its best. I'm really happy with that. So I'll shut up for a while.
Yeah, thanks, Jim. And several members of that team are on this breakout today, so they'll be able to chime in about all of this as well. So thanks for that. Next is Marufa Bouyan. I apologize if I pronounced that incorrectly.
No, you're right. Can you hear me well?
Yep.
Okay, so lessons learned. I think my words might sound philosophical, but it could be very accurate scientific too. So I think the rules we write for others may apply to ourselves first. So whenever we write EVA rules or other things, so we should keep that in our mind. And then I also know that real time and imaginary time both exist at the same time. But imaginary time may travel like 45-degree angle. So I learned that from Stephen Hawking. So when I learned that, and it kind of changed the whole perspective of things. So in this conference, we're doing real-time solutions. So for Mars rover, I have a project, 1 million people on Mars. So I'm the principal investigator. I presented in the conference. So I have like designed Google Earth Pro settlement and all these things. So for rover and versus human settlement, maybe it's different because machine and human affairs, it's like human factors. So sometimes like sound pollution could be too much for human, but for robot, maybe it doesn't matter. Because now that in pandemic, we can understand like how sound pollution could be like very extreme. So some human factors would be, we should keep those in our mind. And what are the other things? I mean, and then also, this is my theory. I am like kind of developing this equation, like time passes at different rate for different people. So on Earth, we have all this time delay, from London to go to Bangladesh and Bangladesh to Hawaii, it could be like 16 hours difference. But on Mars, I don't know, from Olympus Mons to Jezero crater, what is the time difference, time delay really? And from Earth to Mars, we know like there's 20 minutes time delay. So time is what really gets me thinking in, like time and space. So, so time passes at different rate for different people. It can vary in terms of culture, history, language we speak, and all these. I don't know, it really addresses any question, but these are just in my mind. And conference since morning, it was great. Thank you. I'll just shut up then. Thanks.
No, thank you for your insights. Really appreciate it. I think next was Gavin Tolometti.
Just making sure, can everyone hear me?
Loud and clear, yep.
Okay, so hello everyone. I just had a query about the flexibility at all levels in the traverse execution. Would we need, probably during analog field testing and astronaut training, would we want to figure out how flexible the flexibility for these traverse executions should be? Because would we want to know it at a certain level, if it's too flexible, we might find it harder to stick to a schedule because we're not really being very strict on how long we should stay at a site of interest and how long we should take sampling or analyzing one particular sample, because we do know that being too rigid limits what we can do. But do you think we should figure out at what point is when's being too flexible too much?
Yeah, thanks, Gavin. I think Jackie has a comment on that.
Thanks, Kelsey. Yeah, big picture through training and all of our testing of creating the EVA plan, we will make this plan to go to a certain site, go along a certain path, use a certain tool, with acknowledging the fact that when we get there, there could be something different that we want to see, or we want to go around a different terrain feature. So, but you have to have something to start with. So having that time, knowing how long it takes the crew to do a sample, how long it takes to traverse a certain amount of terrain is really important to make that base plan. And to keep that base plan in mind so you know how much time you have to get back to your vehicle. And then knowing the crew, knowing the priorities, like was stated earlier in some of the presentations, and giving them that leeway to address whether they want to do a different rock or suggest to the ground that say, I see something different, I see something new that I think we should adjust to, and have that flexibility in versus just wandering across the place. So there's definitely a balance between the flexibility and the plan that we have. And we are testing that.
Thanks, Jackie. And I think, Ben, you had a response to that as well.
Yeah, I just wanted to say that it could help if you think about it as objectives on the flight plan in detail, as was just expressed by Jackie, as opposed to tasks. I mean, right now we have an EVA system that's very focused on very specific tasks. You're turning this bolt counterclockwise this many times to this torque level. And that's what EVA has been for a very long time at NASA. So if we go back to, when we say rigid, Apollo was nothing like rigid compared to where it has gone. So I think if we saw a recurring theme in the historical material for Apollo missions that everybody knew why they were going somewhere to do something. So when they saw an opportunity for a deviation that would accomplish that goal, they would take it. Or if they heard feedback that meant they were going to miss it, like you heard Jack basically disobey a direct order and get that light mantle sample anyway, because he knew that was our only opportunity to get it. Those objectives and just embodying that, I think, is a very important part of our planning.
Yeah, can I just add to that? I think that's really, really, really important. And this is the whole point of Sergei Krikolev's creativity versus determinism. I mean, as you point out, a lot of the things that you do, they're pretty much task oriented. You have to install this, you have to fix that on the outside of the space station or whatever. They're really critical, obviously, but they're more task, not objectives per se. So objectives are a little bit more loose, and so that's exactly what's going on the moon. And you paint that picture beautifully from my perspective. And I think we have to view them as objectives, which can be met in a variety of different ways. And I really encourage everybody to go back and listen to the voice recordings, the real-time synced voice recordings, and you'll hear what we heard in mission control, which is glass, this green glass. It's like, whoa, it's like, that's a showstopper. What's going on? So they're sharing that with you, and you're not going to say, hey, stop what you're doing. We're supposed to go to the next station. No way. That's a discovery. Same with the orange soil and Apollo 17. So press on in that mode, and I think that's the way to go from my perspective.
Thanks all. Mark Reagan.
Thanks, Kelsey. I have a finding, but I want to comment on that last one as well. That's why you have priorities, well-established priorities, so that you can balance that against the value of the discovery at the moment. And another piece of that is you don't have to trade off between the rigidity of today's plan and the flexibility of today's discovery, at least unless it's the last day you don't. You can always trade off the value of the discovery in the timeline another day to go back and look at this more thoroughly against stopping your today plan to do that. So those are a couple of thoughts on that. But my finding I wanted to discuss, and I don't really understand the finding, but it was clear there was one, was that it was broken and Jim Lovell came in and played some role and that made it better. But it isn't really clear to me what role he played. He wasn't the lead scientist. It seems to me like he was kind of if the scientist can't get an answer together quickly enough, he helps direct that work, or eventually represents the work to the flight director, even if they're not getting it together. But there was something really key there about how his role improved the communication and improved the decision making that was touched upon, but I didn't really understand, exactly what it was. So maybe a little bit of more description of how that worked and
Sure.
how we would reproduce that role intentionally in the future.
Yeah, I can speak to that real quickly. So I think the key here is I don't remember there being mass confusion on Apollo 14. There's always debriefings. This could have been better, et cetera, et cetera. And it was really great to get Jim Lovell in there for sure. Why is he important? Because you're explaining it to an astronaut, okay, who is professionally trained. He knows he is the one that's had the situational awareness in space. And he knows kind of like how to alter that in a way that is going to be able to be transmitted to the astronauts in a meaningful way. A little different on Apollo 17 because Jack, of course, was a professional geologist, but still, that was his major role, and he did a really great job at that. And
You're
again,
describing a Capcom normally, though. Were the Capcoms not trained on Apollo?
They were trained. The Capcoms were essentially the mission scientists for that. Tony England was on, Joe Allen, you heard, and Bob Parker. They went on all the field trips and everything like that. So they had a very good sense of what's going on. But at the same time, you needed somebody to translate somewhat complex kinds of inputs into something that would be simple, okay, to pass up to the astronauts on the base by the Capcom. And that's what happened in the Apollo 15 situation. The situation was pretty complex about the boulder strategy, and if we don't see any boulders, what do we do? That's why Jim, handed me his badge and said, "Go explain it to the Capcom," because it was more science than it was operations, if you will. So I think he did a great job. I think it's essential. I would not rule that out because it does make everybody not talk science, but talk science to the crew who may not all be professional geologists. I think elevating the PI of the experiment, the geology experiment, or something like that, to a co-equal role would be helpful in this. And the other thing is, we're going to the South Pole region. We're probably going to be going multiple times to the same general area. That means we can go back and look at things. That means we can, in fact, we're going to be spending more time on the surface, more EVAs. So there'll be more, essentially, possibility to increase the input to broader scientific objectives that if we didn't get it done this time, that's something to mark. We're going to really look for that either on the next EVA or the 5th EVA after that on this mission. It'll be a lot more forgiving than it was at Apollo, where we're never going to go back to the 15 site on Apollo. So that's another dimension to put in our training, is that if we're going to be focusing here in the South Circumpolar region, there's going to be a lot of ability to learn from each mission, to input in the next mission in a very direct way about sampling, the kinds of things we discover, and so on.
I guess I'm still lost a little bit. Could Lovell not have been the main Capcom and achieved that? Why did we have to insert him back with the scientists? It seems like an extra level of
I think I can help
throughput
with that on why it happened. Some of the oral history talks about the unfiltered voice of geologists and other scientists who are not trained in how to have radio brevity and talk in mission control. So there's like a huge cultural difference between somebody who just came out of being a teacher last term, who's now like in the back room and hasn't trained to be a flight controller. So Jim Lovell was like a wrangler, like he was kind of filtering and translating into stuff that could be acted upon in mission control on the clock.
Exactly right.
My suggestion was that I was like, let's remove Jim Lovell now, because now we can have people that are trained to be in mission control that have the same qualifications as Bill Mulberger did. And those people will know how it goes in mission control. We have 50 years of experience to draw upon to make that happen.
That's exactly right. And I would say that you want to train the two people, the scientist and the astronaut, to be interchangeable. So the scientist has to learn enough to be able to communicate with a Capcom directly and not go into the lecture 3 of basic geology, and vice versa. So I think that's really perceptive and the way to go.
Okay, this is great. I think we do need to wrap up Apollo. We could talk about Apollo for hours, but unfortunately we cannot. So I want to get to the couple folks who have been waiting patiently. So Kevin Sato, any comments?
Yeah, hi. So in terms of the communications between the science room and the flight control, there's been a lot of experience now with the International Space Station as it relates to taking out an astronaut in the middle and inserting a scientist or someone with a science background. So in the work that I did with ISSCOM communications from Ames as the science lead, we actually would communicate to the SOC, which was the Science Ops Comlink, which was a scientist or the lead increment scientist, to provide information to that person, who would then communicate it up to the flight director, to the Capcom for how ISS worked. Now, the reason why that worked was because everyone who was situated in our mission control at Ames had a set of coursework that we had to take in terms of how to communicate appropriately. So you had a bunch of people who talked science or engineering, right, in detail. We had training to be able to now consolidate that and actually speak in a language in a manner that could then be used by the SOC. The other thing too that they would have us do is actually write small memos that we would type in, and then that would get sent up the train, so they could specifically state what we wanted them to say. And if there was any questions, it would come back to us to correct. And it was all done very, very quickly because of training we had. The other thing that helped a lot too was part of that training was actually to sit in on sims, on communication sims, in which we would have green cards, which were problems that would come up, standard activities, and it would be based on an actual flow and activity and operation run that we were going to be doing in flight. So everyone knew how to talk, everyone knew how to communicate back and forth, including that training was also with the SOCs and the lead increment scientists, as well as Capcom and flight directors. So it actually worked out really well. And so there's a lot of experience now with ISS that I think can be easily translated and is likely to be translated over to Lunar, based on talking with one of the flight director at Johnson, who's actually doing work, prepare teams for lunar missions. So there's a lot of experience there. So that could be an area, that you guys can potentially talk with for lessons learned there. But it worked very well, and it had knowledge to a scientist who went up, and it was clean, and our information got there as we needed it to go.
Yeah, thanks, Kevin. And speaking on behalf of Alex and Jackie and our Flight Ops XEVA team, I know that there's a lot of work going on in that area on how to prep those types of sims. And when that broader science team is selected, there's already planning going on how to integrate that broader team to get them the experience that we've heard is so critical all day today. But again, in the interest of time, I just want to take two more comments from Zach and David because they've been waiting, and then I want to move on to Mars. So Zach, take it away.
Thanks, Kelsey. Hi, everybody. This is a slightly different tangent, so I apologize if I'm shifting gears a little bit, but still within the Apollo realm. One thing just to point out, it's a little bit obvious that we have access to that they didn't during the Apollo missions was online resources such as Microsoft Teams and Slack and all sorts of different programs that allow us to communicate over distances but still be together as a group. So I was curious if people thought at what point these tools will have an impact on the structure of the science support room to become, at least on some level, less of a science support room and more of a science support group where you could bring in experts from multiple different institutions or even early career scientists and have an easier time getting early career folks and a more diverse group of folks in, or at least have a chance for their voice to be heard. Because these meetings have worked really, really well being remote and virtual. I think given the last year of experience, there might be a chance to have even a level down in the organizational chart, just a link to a more broader virtual input group for Artemis science support operations.
Yeah, great point, Zach. And I think, 2020 and 2021 have taught us all how to use these a little bit more effectively. And I think I'd also like to hear more in the Mars conversation because I think as Ashwin pointed out, there's, hundreds of scientists, 40% of which are international, and they're not doing all of the science with the Mars rovers in person together. So I think there's probably a lot of lessons learned we can leverage from that community as well. And I also encourage you to attend the first breakout tomorrow because that's one of the topics that they hope to discuss is how to facilitate that kind of remote participation, but also software to enable the in-person collaboration as well. So thanks for that. David, and then we'll move on to Mars.
Thank you, Kelsey. I want to make 2 points. The first one is to address the question that came up, and I know I'm going to repeat what a few people said, but it's important sometimes to reinforce it. And the question was, how much autonomy should the crew have? And as Jackie said, prioritization, pre-traverse prioritization, your flight rule is, of course, your first boundary. But the other thing, and I mentioned this earlier, the integrated sims, where you go through mission exercise after mission exercise, the science team and the crew develop a level of trust, and it takes very few words between the two once that trust is established. And Kelsey, you know this, you were one of the crew, to make a point. And if there's that trust, then you trust the decision that you're hearing on the other end of that comm line. And of course, if there is still some uncertainty as to what was decided, at least during Constellation, we were doing daily debriefs with crew, and we would discuss those points. And as you discuss those points, the number of those conflicts, again, plummeted. And so that is, I think, the path forward that we'll see with Artemis. But I think the most important point that I want to make for the topic that you have here and the question that you ask is that the Apollo Science Support Team worked, but it didn't work. I mean, it was an extraordinary success. I mean, we heard from Jack and we heard from Jim. It was extraordinary success, but those were for very short EVAs, well, 8-hour EVAs, 7, 8 hours, but short missions is what I meant to say, and a limited number of EVAs. In Constellation, with FOD support and guidance, we tested this concept of having an integrated science and flight operations center. And that just greatly enhanced the productivity during EVAs. Now, there is a problem that was brought up, that scientists don't know how to communicate on flight loops and so on and so forth. But that's an issue of training. So at the very same time we're talking about training crew, we should be talking about training the science support staff. And again, with FOD support, we've set up the first element of that. We have a space flight resource management training for science ops on the books. We would have held it last year if COVID hadn't interfered. And we can train scientists to work in a flight control environment, but it's going to take training. And so I think that one of the findings should be we should have science ops in the FICR. Thank you.
Thanks, David. And I want to pull on that thread a lot more during tomorrow's breakout number 2. So bring that thought again tomorrow. Okay, so I want to move on to Mars, and I see we have a few Mars folks in the group, which I'm really excited about. So I tried to pull some notes from our 2 Mars talks today, which is not this slide. Here we go. So I think, a particular interest is the fact that the Mars rover missions have really been so successful with these incredibly large, wide, multidisciplinary team. And of course, you, like everyone today, emphasize the importance of science and engineering. But I was really struck by the numbers, Ashwin, that you mentioned. And you touched a little bit on, and both out loud and in the chat, about how you kind of structured this really large and diverse team. But I think we have a lot more discussions we want to have with you guys on how we can, structure this effectively. Points you mentioned that I wanted to just bring back to the conversation are, the team's partially co-located and partially remote. I think that's a model to think about as we build toward longer lunar surface missions. I really liked your phrase, strategically planned but discovery responsive. I think we talked about that already exhaustively with the Apollo lessons learned, but the fact that we heard it echoed from you is I think really illustrative. You again emphasize science embedded in engineering teams. That's more the focus of breakout number 1 today, but still that your point struck me. Scientists are partnered with engineering and leadership roles. Working groups are chaired by scientists. The science team staffs a geologist as a liaison between the science team and robotics engineers. That was a specific example you gave, but I think you gave it to illustrate a larger point about the importance of that kind of crosstalk. And then we heard Fred talk a lot about data products as well. I think that's really the intent of the first breakout tomorrow. But again, I think it's worth noting that you guys have really done that so well, this sort of meshing of science and ops products. And another thing that I want to talk about again tomorrow is this idea of sort of a dedicated mapping team that gets more at the structure. But I think there's a lot of really, really critical questions to learn from here. I shamelessly screenshotted your org chart here. This is what we're going to try to get at tomorrow. But I think maybe what I want to dive into first is just how you guys structure everything. I was not a part of either mission, but I recall seeing talks about both MER and MSL and how you broke things down either by instrument or by science discipline, like to use a Lunar South Pole example, volatiles team or a impact cratering team. So I think I'm just really interested in hearing from you guys a little bit more on your perspectives on what we can draw from how you have structured such large and interdisciplinary science teams that we can take into Artemis. So Mike Siebert raised his hand first, so we'll turn it over to Mike and then Ashwin.
All right, I wanted to chime in from my past experience. I was on the Opportunity Rover project for 12 years as a flight director and a rover driver. So now that the bona fides are out of the way, something that we had found, at least on Spirit and Opportunity, that in the later missions that really helped, that can be baked in kind of from the beginning, is that we had an engineering team that was curious about the science. We wanted to understand what the science was, what the discoveries were, all of that. So by understanding the science objectives, the engineering and operations teams are able to better plan how to maneuver the vehicle around to potentially, if you're trying to do a contact with a rock, you may want to do a dog leg to get there to line the vehicle up to be able to do whatever drilling or sampling or contact science you're planning on. But on the other side of that coin is we had a science team that became very well versed in the engineering capabilities of the vehicle. So for the moon, the analogy would be probably the rover and the crew on EVA. But having engineering understand the science at a high enough level, but still enough detail to be able to have that inform engineering and operations decisions, and have the scientists understand the engineering so that they will ask for requests to do something with the vehicle that might be pushing the capabilities to their whatever the maximum that can be done, but to fully utilize the capability that's on the surface. So instead of kind of being timid about, oh, is that slope too steep? I don't want to ask to see if we can reach that target. It's go ahead and ask. Use the knowledge that do you think that's within the capabilities. So that was a big thing I wanted to highlight. The other one was kind of a science and operations interaction paradigm that we developed, at least on Opportunity. We had much cruder tools than Curiosity and Perseverance have. A lot of times the rover drivers, we'd get images down, and in the image, the science team's looking at the same image, and we'd be told we want to drive over to an area in an image or put the robot arm in contact with an area on an image. And the description would a lot of times come across a conference call line on speakerphone saying, okay, well, there's that kind of diamond-shaped rock in the upper right of the image. If we could contact the part that's kind of to the lower left of on that rock. And the request from the rover drivers would always be, can you put a dot on the image? So basically send us a PowerPoint slide real quick with a dot on where you want us to park the rover. And thinking forward to Artemis, now that we're going to have higher rate comm, not only coming back down from the moon, but also with the ability to do data uplink to the crew and not just voice, it may be advantageous to have the ability to send those, not only the maps, but either images previously taken from the helmet cam or the cameras on the rover, to actually put a dot on it from the science teams in the support room saying, we would like to go get a closer look at this. So instead of time trying to interpret just an audio request, it's, oh, okay, I know exactly where that dot is on this large outcrop. I can walk right over to it, and then we can get into the detailed investigation. So that's kind of the lessons learned from at least my experience that I think can be ported forward to Artemis EVA work.
Yeah, thanks a lot, Mike. Really appreciate all that insight. Ashwin.
Hi. Yeah, just pick up quickly on Mike's last point before I talk about the organization. You know, what he's saying is exactly right, of course. And the way, you know, the point, one of my bullets that you read, Kelsey, was the way we had tried to address that on Curiosity, which is instead of trying to send PowerPoint slides with dots back and forth and audio commands about, you know, audio instructions about what the left side of the rock and all that, we try to have a knowledgeable, you know, scientist, a field geologist, really sit really at the same workstation with the robotic engineer so that they can in real time iterate, because we get the sense that the science team can communicate to that representative very clearly, and then that representative being physically located and able to iterate in real time with the engineer can then relay that message the best. Anyway, I'll move on from that. I think the overall point of that in my slides was just put scientists as proximate as you can to where they can be helpful. So with the organization, I'll try to make this very brief, but we have the 500 people, and I don't know how it will work on Artemis, but the reason we have these big teams to begin with is because we have 10 independently selected payload investigations. So NASA selects, based on a competitive process, 10 payloads for Curiosity, and they each come with a science team. So quickly, you already have a few hundred just from that. And so that sets kind of the organization of the team when you're not talking about operations, just as a science team. They're broken into instruments with PIs. But because we're operating a rover, and I can see this happening the same, even more so on an astronaut-based mission, where everything's in real time and you have to make decisions that affect all the science you're doing at once, you can't have this 10 different voices. So we've integrated the team by choosing representatives, staffing a science operations team that's much smaller. I mentioned the 35 or so roles every day that participates in team-wide discussions, is very much up on exactly what science we're trying to accomplish, but they're the only ones who participate daily in making these operations decisions. And with even within that smaller team of 35 or so, there's a hierarchy where there's a leader of that science operations working group who has the final decision. So it's all structured to try to draw the best overall expertise from having this wide, diverse team, but realizing that we have to speak with a single voice and make quick decisions when it comes to actual operations.
And can I ask, how does that SOG chair interact with the person who's responsible for sending up the commands to the rover?
Yeah, so we start out each day, including today, with the scientists working, looking at the data for about an hour or so, and they have their own phone meetings for a geology working group and an atmospheric science working group, and they start putting together their ideas of what they want to do, and that then gets documented in a what we call a plan fragment, just the part of the plan that has the geology observations in it. And then we have a meeting where it all gets reconciled into a single plan that gets uplinked to the rover, including all the engineering activities. We know how much power we have, all those things. That is what we call the SOG meeting, the Science Operations Working Group meeting. Consists of all the relevant engineering roles, all the relevant management roles, mission assurance, and the person who leads that 2-hour discussion is the SOG chair, is the scientist. And so this gets at with the flight director right over their shoulder. But we have, this gets at the previous person's point too about actually two talks ago, where we spend a lot of time choosing those people who are SOG chairs very carefully, so they have the skills to interact with the engineering and management team and make and understand the risk issues and all the things that go into that, similar to putting a scientist on the voice part of a human mission, as was just talked about. So, we find people who have the skill set to be able to operate in that engineering and management environment.
Thanks.
And also could still represent the team adequately, the science of the mission.
Yeah, I think that's a really important point. Lauren, and then we're going to move to ISS.
All right. Yeah, no, I think Ashwin gave a great overview of the operational roles for MSL. But one thing I don't know if it came up in discussion was kind of another way that the team is organized by themes that we're interested in. So, for example, we have like a sedimentology and stratigraphy, breakout group that meets on a regular basis, or one structure that we have experimented with, and it's something to consider for Artemis, I don't know, is having campaign leads for particular outcrops or investigations. So there's kind of another structure in addition to just the operational roles that are happening. It's like, how is the science interpreted in these ways? So.
Yeah, that's great. And I think there's a lot more conversations that we don't have time for today, given, leveraging which of those lessons learned are going to be appropriate, especially as we get to longer and longer Mars missions, right? Lunar missions, because you guys are so used to, having the luxury of a little bit more time than say we talked about with the Apollo mission. So there's some sort of balance there that I feel like we need like hours just to pick your guys' brains on how you handle all this. So thanks very much. Fred, got a quick point, and then I want to move on to ISS.
Sure. I just popped over from the meeting. I just saw my name a lot on this slide, which is great. If you had any questions, feel free to ask. Otherwise, I'll let you go on.
Oh, great. Okay, thanks. Yeah. Yes, I'm glad all you guys are here, and we have touch points to all of these questions that we're sure to have in the future, especially as Jose and I put these reports together. So thanks very much. Okay, so moving to ISS, and I'm glad we still have our FOD colleagues on. Again, I just pulled out some notes as Jackie and Alex were talking earlier. Again, feel free to hack and refine these as necessary. Just some points that, especially this is going to apply as we have the longer term missions and potentially crew that are on the surface and not actually EVA while their colleagues are EVA. We have the ground IV now that talks to the crew while the Capcom remains the prime communicator for the rest of the IV crew. We have heard a lot today already, and I expect we'll hear a lot more tomorrow about the ideal comm structure for Artemis. We've heard a lot about the idea of a SciComm, and I know a few talks tomorrow we'll talk about that as well. A few things Jackie mentioned that I wanted to pick on are, if operations are proceeding nominally, the FCT is in receive mode. And we heard a lot about this from folks like Jim in the Apollo session about, train them, trust them, and turn them loose. We want to make sure that the crew is empowered to make those observations. And we as a science community need to understand when we want to feed up recommendations and suggestions for changes to the plan, which should be minimal, knowing that we're going to have a really well-trained crew in place. And then during off-nominal operations, the flight control team is ready to immediately direct the crew. And she mentioned the idea of a crib sheet, which enables us to, on the ground, to really quickly respond to a number of pre-planned issues that might come up. I'm just curious, to hear thoughts from the community on what those might look like for science operations. We're used to a station, operating under, safety concerns and what those off-nominal operations might look like. But we should think about reacting to deltas to what we expect scientifically and training for how to accommodate those contingencies, for lack of a better word. Jackie also raised the importance of get-ahead tasks, which I think is going to be really interesting scientifically as well. I just wanted to put that in all of our brains to think about. The controlling authority issue has come up a lot, and we really need to wrap our brain around that for having clear direction and agreement on controlling authority. So when a decision to the traverse plan, when a decision on a change to the traverse plan is ready to be kind of implemented, who has final direct and controlling authority on that? And there's obviously a lot we need to learn from our ISS colleagues about how they work that today. Jackie also highlighted the importance of, during operations, not just leading up to, like we've heard a lot about today, but actually during operations, the thought of integrating meetings and events and just pre-planned touch points to allow the scientists and the operators and the flight controllers and everybody to touch base on how things are going. Support plans such that working level personnel have direct access to each. I think this is in the weeds a little bit compared to the rest of the points, but I think that was an important point that she highlighted that we want to build into this planning process. And then, of course, we've talked about this a little bit already, and we're going to talk about it a lot tomorrow. And that's, as ISS has today, they have a systems and a task position with which both Jackie and Alex talked about their roles and responsibilities. But, we're adding a whole different set of objectives that come with a different position. Where that position sits, we've heard a few people express opinions on that today, but we have a lot left to learn on kind of what that role actually looks like for this EVA science officer or exploration science officer. So those are just things I pulled randomly from Jackie and Alex's talk, but want to turn it over for other lessons learned we can leverage from Station, and over to Cindy.
There, okay, I got the mute off. Yeah, so I think that the one thing that Station lends is also the ability to do science in a pressurized enclosure, which for sustained operations on the lunar surface, we're going to have EVAs, we'll have pressurized rovers, we'll have IVAs from a pressurized habitat, and we'll have science inside a habitat. So you're going to have a huge continuum of kinds of science to get involved with. So I think that's going to be a challenge because you've got so many different modes there. Station in particular, there's the EVA lessons, but there's also the how do you do science on the station lessons. And that's evolved a lot over the last 20 years. And probably, some of the people online can answer that better than I can. But now, in fact, PIs can work with crew members in a scheduled way to help perform science on the space station. So it's so there's a lot of trade space there. I guess that's my comment.
Thanks, Cindy. And I saw Kevin's hand pop right up. I think I can see why. Kevin, take it away.
Yeah, so a couple things from ISS Lessons Learned. This might fall into the get ahead, but my understanding is get ahead was stuff that the crew could do to prepare. But they also have what's called job jars, in which if the crew completes work earlier, they have extra crew time available. They can then select something that they have time to do and they just go do it. Right, so it's possible that when they're on EVA or they're doing some other work or analysis, they can have a set of things they can go to do that it's already pre-described by the science team. So that usually works out pretty well. Also, what we started to learn on our end was really it had also to do with crew training. Early on, we had really tight crew training and how we handled it. However, we also started to get our scientists involved. So we had, and this is also from the early days, which I think you all know about from Shuttle, where there was standard crew training, but also there was a crew briefing by the scientists, either the project scientist lead or the PIs, in which they would talk and explain their science to the crew, and the crew would be able to ask questions. And so they were able to get a significant amount of that, but also they got a lot of one-to-one. And then towards recently, we've had enabled the crew, the flight directors have enabled some of our scientists, based on the research that we were doing, to actually talk directly to the crew. If the crew was wondering how to do something, or they were seeing something odd, or they wanted to try something different. This was like for the plant side. And so they were able to explain it, and the crew really appreciated that, because now, rather than getting something from someone in between, they could ask the person whose science it was directly related to. Doesn't always happen, because you got to be control what the scientists say, so we have to talk to them. But they found that extremely useful.
Hey, Kevin, this is JC.
Yeah.
Just while on top of that, there's people who are enabled or trained by the Huntsville folks to be able to communicate with the astronauts. So they have the ability, and the Huntsville folks have the ability to enable and disable the PI as necessary. So that's a great offer for especially some of the more problematic experiments that we have to run, or complicated. So.
Yeah, thanks to both of you. Jackie. Oh, she just disappeared. While she makes her way back, Loredana.
Hi, yes. I mean, it's not exactly ISS, it's not exactly Mars, but I think it covers one of the issues that were mentioned about covering the problem between having a lot of time to do planning during Mars missions and having a very short time during Artemis missions. I don't know if you're familiar with the LEOP operation, launch and orbit insertion operations. The teams that to control satellites during the LEOPS operation, LEOP, LEOP operation, they actually have very short windows in which the flight director and a couple of other people come out of the room. They break out. They have a very short window to take decisions, but the key people are in there, and they actually have a very structured decision process in which they have that amount of time, and then they have to go back and give a command. And I think that might be something to think of for Artemis.
Yeah, thanks. And I see Jessica Watkins made a similar point in the chat that I just saw for the time scales over which decisions have to be made. So I think we definitely need to weave that into the narrative for this report, because I think that's obviously critical when you think about science decision making and tactical versus strategic science decision making. And Jackie's back, so over to Jackie.
Yep, sorry, I hit the wrong button. I just want to make sure, as we're thinking about this and taking ISS science into account, we're realizing that they're in a pressurized environment, so it is definitely going to be different. It needs to be treated differently than when you do science outside the vehicle due to the critical nature of an EVA. That is why having an integrated story that goes forward to the flight director, not just science, but including your suit and your resources and your health status, all together jointly and going up as a joint decision is really important in the critical nature of an EVA.
Yeah, thanks, Jackie. Kevin.
Oh.
Or was that hand old? Great. Okay.
I put my hand down.
Yeah, no problem. I do that all the time. John.
Yeah, one of the other tools that ISS uses and Huntsville folks do in concert with ASC is a piece of software called Optimus Viewer, and it's a wonderful software tool. It captures astronauts' schedules through each day, including their exercise and stuff. And I know with the excursions, the EVAs on the lunar surface, all the astronauts on ISS have a tablet that they pull this up on, so everybody's on the same page. And one of the things with Google Glasses coming out and that technology is that even on these excursions, maybe this software type package can go with them. It includes everything from procedures, timelines, task list stuff like Kevin was talking about, job jars, stuff like that. It's a wonderful tool that actually empowers a lot of people to be on the same page across the mission.
Thanks. And again, I hope this kind of thing comes up in the first breakout tomorrow. I think it's really critical to summarize a lot of those lessons learned. Fred, is your hand still up from before, or do you have an ISS comment? Okay. Okay, so we only have a few minutes left, so I would like to encourage a moment for anybody who has not participated yet today to do so. So if we have not heard from you and you have a comment on any Apollo, Mars, or ISS lesson learned or finding, Heather, yes, go ahead.
Yeah, sorry, I actually missed the first part of this discussion about the lunar stuff, so if this was already mentioned, my apologies. But I was at a workshop for at Brown University, I believe it was, a few years back, and they brought us into a cave type unit, and they were talking about how they've had some really neat discoveries by working with some of the Apollo astronauts in that environment, and them being able to be immersed and bring back memories of certain aspects of discovering particular outcrops or rocks, or different other geological features that were interesting. And so I'm wondering if somebody had already discussed the use of that kind of a tool, immersive tool, beyond like VR, where the scientists could be in the environment live with the crew, real time for moon operations, to be advising. So they're seeing what the crew is seeing. I don't know if that was already discussed, but I thought it was a really interesting experience when I was there, and the insights that they were gaining this much later on, in the future, from when the original discoveries had happened, by bringing them back to that environment.
Just a quick comment on that. That is indeed what we did. We have a great immersive, complete 360 immersive virtual reality facility at Brown, and we brought the 21st astronaut training, and indeed we had Dave Scott there, and we flew a descent profile into Hadley Rill at the landing site, and then started going around looking at the different things and doing exactly what you were just describing, Heather, and we couldn't get them out of there. We could not get them out of there. There was great discussions. Immersive virtual reality in a 360 environment where everybody's participating can really be a helpful tool. Thanks.
Yeah, and I thought I was at it was the conference, the Space Horizons conference that I was there for, that we got to see that, and I'm just thinking that would be a great tool to use in real time for current missions, for Artemis missions, to be able to, if that could be live streamed and integrated into a cave, that the scientists on Earth could be there with the astronauts if there was a reason to have that kind of collaboration between the Earth and Earth scientists and the crew.
Yeah, thanks a lot, Heather. I think there are even a couple talks that touch on this as well tomorrow, so it's a well-timed contribution. And I think Jose in Breakout number 1 tomorrow is hoping to capture that kind of want to, kind of have technologies that will facilitate the integration of the science team with what's going on the lunar surface. So I think that will not be the last time we hear about that kind of technology during this workshop. So thank you very much for that. And it sounds like we have some experience in the group here today with using those kinds of technologies, which is great. Okay, so we're up against our time here. Yes, and Kirby points out that his talk tomorrow will touch on that as well. So we'll hear more about that. So thanks everyone for your participation today. I think we heard from quite a few of you, so I really appreciate that. And I hope that you bring these opinions and contributions tomorrow as well. Jose and I and Amanda and all of our other facilitators are gonna work on writing this up, and we'll get a report put up on the LSSW website in a few weeks. And it will be open for community comments. So if you did not get your thought in today, or we don't capture your thoughts correctly, there will be a period to capture all of that feedback for you guys. So this is not the last time that you'll be able to contribute to these conversations. And as you heard Jake and Sarah say at the beginning of today, we also envision future workshops that will touch on a lot of these topics as well. So we hope that there will be a lot more opportunity to gather all of your feedback, and this is just the first step. So thanks again to everybody. Thanks especially to Amanda for helping me capture all this great info. And I really hope that you can make it to tomorrow's workshop. Jose and I will summarize how these breakouts went in the first 10 minutes, and I'll try to distill a lot of these disjointed notes into some cohesive points. So if you have thoughts after you see my summary, please don't hesitate to reach out to me directly and use Jose and I as a resource as we prep these reports. So thank you very much. And we look forward to more dialogue with the community tomorrow.
Thank you, Kelsey. Great session. Really great session.
Thanks a lot, Jim. Thanks for your talk.